in order to add and subtract a fraction? You got to have common denominators. So if we're going to add and subtract fractions, if I have 2/3 plus 1/3, do I have the same denominator? I do. Since I have the same denominator, I always just write that down. I don't change anything. And now I do the tough stuff. 2 plus 1.
I'm kidding, it was a joke.
Are you sure?
Yeah.
I don't know about that one.
100% sure it was a joke.
Oh, Drake.
Now, can I do anything with that fraction then?
1.
Yeah, I simplify it out and get 1. Thanks, Lee, for waiting. When we're dealing with fractions that don't have common denominators, what did you have to do? You had to make them. You had to make common denominators. If I'm looking at 4/5 minus 1/2, in order to make a common denominator, the easiest way to do that was to find what's called the least common multiple, the LCM. You remember that vaguely?
Yeah.
It's what that means is that we're looking for the smallest number that both those go into. In this case, what's the next number that both 5 and 2 go into? 10. We could figure that out a lot of times by just multiplying them together. So my common denominator here would have to be 10. Now, when you guys did this, you had to be able to figure out what do you have to multiply the 5 by to turn it into a 10. You had to multiply it by a 2. But if I multiply the denominator by 2, what do I have to multiply the numerator by 2 as well.
Not 5. You said 5.
You guys have done this step a bunch of times already in this class. When we had to rationalize our denominators with the square roots, when we had to get rid of imaginary numbers in our denominators, you all are always multiplying by some factor of 1. What's 2 over 2?
1.
1. The other one I have to multiply by 5 over 5, right? Which is also 1. We're using the same idea here that we've been working on before, but now what's 2 times 4? 8. You notice who's being quiet over there? What's 1 times 5?
5.
And now when you're done, what's 8 minus 5? So my answer is 3 over 10. Those generic properties of working with these things to find common denominators and whatnot don't change whatsoever when you're dealing with stuff with variables. Nothing changes. For example, I'm looking at this one. 2x over x plus 5 plus 7 over x plus 5. Do they have the same denominator?
Yeah.
Okay, what's the denominator?
X plus 5.
Okay, so your common denominator is x plus 5. What do you do with your numerators then?
Just add them together.
Just add them together. Is there anything else I can do here?
You could smile.
I can smile, yes. Can I simplify it?
No.
I guess you could simplify
No.
No, you can't because there's addition.
In this case here, I can't simplify it. There might be from time to time, let's say this was 2x plus 8.
Yeah.
I could factor out a 2, something might happen where something else might drop out. But in this case, it doesn't happen there. What?
Like, if you had 8, like, would you have to factor
When we come across that, well, I'll show you what's going to happen. All right? So this is an example of something that has the common denominator. Same process, same thing goes. What's going to happen then when we don't have that? When we don't have common denominators, we have to create the common denominator. Just like you guys did when you had 2s and 5s, 4s and 6s, 3s and 4s. You still found a common denominator by factoring things out and figured out what they had in common. The same exact properties that you guys learned in 4th or 5th grade when you worked with fractions apply to when you're working with them with variables. None of that changes. Okay? None of it changes. What we do here is we start by factoring all of our denominators. If I'm looking at that first fraction, it's 5 over 6x squared. Can I factor anything with the 6x squared?
No.
No. I'm just going to rewrite it then. Can I factor the denominator of the second fraction?
Yeah.
How?
Well, we take the square root.
Take out a 4x. Very good. Factor out the 4x, and you're left with x minus 3. Numerator still has an x in it. Everybody agree with me on that?
Yeah.
Now, take a look at that second fraction. Is there anything you can do to that? I can take out the x, can't I?
Wait,
Why can I take out that
it's
x?
multiplication.
Because it's multiplication. Just like you did yesterday when we multiplied all that stuff together, when you had that string of terms put together via multiplication, now that we have this x here and this x here, they simplify out. What now goes into my numerator? A 1, good. So as of right now, we have a new fraction. First one's the same, 5, 6x squared, plus 1 over 4 times x minus 3.
Bless you.
Now we have to worry about our common denominator. Again, when I'm talking about the least common denominator, I want to look at what you would do if you had just a 6 and a 4 to get a common denominator. What's the least common denominator of a 6 and a 4?
12.
Somebody wanted to say 24 because you multiplied them together. And that's all right. The least common denominator is 12. The least common denominator is going to be 12. And the reason why you guys can say the least common denominator is 12 is because you factored that into prime values. 2 and 3. 2 and 2. What do those two guys both have in common? They both have a 2, right?
2.
What's left? 3
3.
and a 2. When you worked with least common multiples, when you worked with greatest common factors, things like that, you always broke it down to the prime factors as far as the numbers were concerned. You wrote down what they had in common, then filled in the blanks. This is where you get 12. You're right, 24 would work, but later on, I'd have to factor that out later. It's easier to work with the smallest denominator as possible. That's how you get the numbers first. Okay? So I know for now, let me move this up, that my common denominator numerically is going to start with a 12. X squared, that's a multiplication term, correct? Is it on the other side?
No.
So we write it down. The term, x minus 3, I'm calling it a term because it's in parentheses. That's multiplication, correct?
Yeah.
Is it on the left side?
No.
So it needs to be common, so we multiply it in. What we have just done there is factored out what did they have in common? Well, they have in common, the least common multiple they'll have is 12. Now, as far as the other terms are concerned, x squared and then x minus 3. Same idea like I did here numerically. When I factored the 6 into a 2 times 3, I factored the 4 into 2 times 2. They both had in common the 2's. We wrote one of them down. What was left? A 3 and a 2. I put them here and here. It's the same process, but there's letters. That's it. Okay? You have now a common denominator. Bless you. What's up? What's that? Oh, here with this one?
Yeah.
No, all I was doing is showing you guys why you want to use 12, not 24.
Oh.
That's all. Okay. So now when I go back, How do I turn a 6x squared into a 12x squared times an x minus 3? Better yet, how do I turn a 6 into a 12? What do you have to multiply by? 2. And it has the x squared, right? Does it have an x minus 3? So I have to multiply the top and bottom by 2x minus 3. So you have 5 times 2 times x minus 3. The fraction on the right then, it has a 4 and the term x minus 3. What do you have to multiply the 4 by? And what do you have to multiply by the x minus 3 by? X squared.
Oh, dear.
What you're doing here is you're taking a look at this denominator. What do you have to multiply the 6x squared by to turn it into 12x squared times x minus 3? You got to multiply it by a 2 and the x minus 3. The second part, yes, sir?
Why is it minus?
Because it should have been a plus.
All right.
I thought I was doing a subtraction problem, I'm sorry. And then on the fraction on the right, I have the 4 times the x minus 3. And I have to turn that into the 12 x squared x minus 3. So again, to turn the 4 into a 12, you have to multiply it by 3. Then you have to multiply it by the other missing term, which is the x squared. So your new numerator is ready to be multiplied together and combined like terms. The denominator, you'll leave it as is. What's 5 times 2? So this is 10 times x minus 3. What's 10 times the quantity x minus 3? Okay, so I have 10x minus 30. And then on the other side, I have 1 times 3 times x squared. What does that become?
Why can't you just cross off x minus 3 from the bottom?
Because I get the right button. What is this?
Plus sign.
Oh.
Um,
Actually, it looks like
It looks like a pill that you.
That's a plus sign.
But it needs to be
You can't, it has to be multiplication. Yeah. Since this is an addition problem here, stop. You cannot simplify over addition. Remember a puppy dies?
Oh, you.
So now your denominator is the 12x squared x minus 3. Now, if you look at that numerator, isn't that the same thing as saying 3x squared plus 10x minus 30? Is there anything they have in common? No, I can't do anything there. What would 3 times negative 30 be? Is there anything you can think of that is multiplied to get negative 90 that'll add to positive 10?
Not off the top of my head.
I'm going to say you're done. And you're done. You always combine your like terms on your numerator, and you leave the monomials multiplied together on the denominators. Yes, ma'am?
why do you multiply the top by the 2x or 2x minus
What do I multiply 6 by to turn it into a 12?
4?
What do I multiply the x squared by to turn it into x squared times x minus 3? That's why. Let me show you one that's not as complicated. I wanted to show you the scary one first.
Was that one scary?
Kind of.
Scary, yes.
Is it going to be like kind of like a test?
I don't know. I haven't written it yet.
It's a quiz.
You know I don't give straight answers. Come on.
Is that this Friday?
Only crooked ones.
7 over 5x plus 8 over 3x. When I'm looking at this problem, do both of those denominators have something in common?
Yeah.
What do they have in common? They have an x in common. You're getting ahead of me here. I'm looking at just what they have in common to start with. Is everybody okay with that? They both have an x. I write it down. Now what's the least common multiple of 5 and a 3? Now it's 15. Okay? My common denominator now will be 15x. What do I have to multiply 5x by to turn it into 15x? 3. So I just have to multiply this one by 3 over 3. Or I have to multiply the 8 by, or excuse me, not the 8, but the 3x to turn it into 15x.
5.
What's 3 times 7?
21. Plus.
What's 21 and 40?
61.
Can I simplify that any further? No. 61's a prime number. Okay. Again, the exact same process we just did in the other problem, where we figured out what they all had in common. The least common multiple, and the other one was 12. This one's 15. They both had a value of x. We wrote it down in the denominator. And we worked out of it. The process is the same thing over and over again.
It's just a system.
It doesn't change when it's subtraction. The first rule of all of these is to factor. You always factor first. So when I have the x plus 1 over x squared plus 4x plus 4 minus the fraction 2 over x squared minus 4, when I go to factor that out, is there anything I can do with that first numerator? No. There's nothing I can do with the first numerator. But the first denominator,
X plus 2, x plus 2.
very good.
Don't hit my arm.
So the first fraction, you get x plus 1 over x plus 2, x plus 2. Can't factor anything with the 2.
Oh, yeah, right.
X squared minus 4.
X plus 2, x minus 2.
X plus 2 minus 2. It's a difference of squares again, guys. A difference of squares.
Oh, did you? Yeah.
Your next step. Look at look at your denominators. Do the denominators here have anything in common?
Yeah, x plus 2.
They have an x plus 2 in common, correct?
Yep, I know.
Since they have one of them in common, I'm just going to kind of mark off that I've accounted for it. What's left?
X plus 2, x plus 2.
X plus 2, x minus 2. Very good.
Well, you just have to throw those in.
Yep, that's it. What you're doing is you're looking for what they have in common. You write down whatever things they have in common. You only write it down once, and then from there it's a matter of filling in what's left over. All right? Now, my common denominator is going to be x plus 2, x plus 2, x minus 2. The first fraction is missing what? An x minus 2. Very good. So you have x plus 1, x minus 2. Minus, what's the second fraction missing? X plus 2. And again, you have now set up the problem to be able to combine all of your like terms in your numerator, but leave the denominator in that factored form. Okay? Can I cancel anything out? Once again, why can't I cancel anything out?
There's a subtraction.
Because there's a subtraction sign. Okay? So I wind up with x squared minus x minus 2. I just FOILed that first one. Distribute the second, I get minus 2x minus 4. So the string of my numerator will look like that. Combine the like terms. A couple other people throughout the day today have asked, can they write x plus 2 quantities squared? Perfectly fine, doesn't matter. I usually just write everything out. And then lastly, Can you get anything to multiply to be -6 to add to -3? And you're done.
You don't have to pay attention to the denominator.
Nope, don't multiply out the denominator.
Why did you change the numerator to
Because when you get to this point here, when you're sitting here, you still have something to do. You still have to be able to combine like terms, because there might be an instance where this was what times what is -6 to get you to. That might be able to be factorable. And if it is factorable, sometimes you might find something that simplifies out. You always just stop for a quick second just to check and see if you can. Not always will, but it is a possibility. Yeah.
Can you explain one more time how you got the numerator?
When I start the problem out, again, we list out what we have in common. We had an x plus 2 in common. Shh, ladies, come on. We wrote it down. What was left? An x plus 2, x minus 2. We wrote it down. When I go back to the fraction on the left-hand side here, this has 2 of the x plus 2's. It doesn't have an x minus 2. So I have to multiply it by an x minus 2. Over here, it has an x plus 2, x minus 2. It's missing another one of these. So it has to be multiplied by the x plus 2. Then it's a matter of foiling and combining like terms. It works the same way as you had the 2 tenths plus 3/4, I guess, I don't know. When I go to factor these things out, this is the same thing as 2 times 10, or excuse me, 2 times 5. This is 2 times 2. What do they have in common? They have a 2, and then the other one is a 5, and then a 2. So the common denominator would be 20. This one has a 2 and a 5, it needs a 2. This one has a 2 and a 2, and it needs a 5. It's the same exact process, but just looks ugly. All right? It's the same process. Deal with the terms as far as they were numbers, and it works the same. Adding and subtracting to these things, we use this a lot more tomorrow when we start setting things equal to when we're trying to get common denominators. You'll see that it works out real clean. But the fun ones, I am.
You can't do a fraction in a fraction.
Yes, you can. And you've done this.
That's not legal.
What do you mean it's not legal? Yes, it is. You've done this problem before. No, you guys are all part of the Wambulance.
How did you know?
Because you guys always whine about things. Because you whine. So you have to ride in the Wambulance.
It'll take me away from this problem, I'll do it.
You really?
What's 1 plus 3 again?
That was a joke.
Sure it was.
And it will make it comes down to.
Now, before you get all freaked out by that, which I guess is too late, isn't that the same thing?
No.
2/3 divided by 1/2, isn't that written vertically?
What are
So
you
can't you just
doing?
multiply?
How many fractions do you put inside other fractions?
I don't know.
Eight fractions.
This is just a division symbol. It's just showing division. Isn't this the same thing as saying 2/3 divided by 1/2?
Then why can't you write it as division instead of writing it as a fraction?
Because we're saving paper. Which isn't that the same thing as 2/3
I think that's
times
making
2
it
over
more
1?
paper, actually.
Yeah.
Okay.
Can you
So if I'm
not?
looking at this, wah. When I'm looking at this, do I need to do anything with this top part? Is there anything I need to do here?
No, you can't do it.
There's no common, the common denominator is just 2 over x plus 2. It's just a term. And the bottom part, I need to get a common denominator to make that stuff work, right? So I'm not going to worry about the numerator fraction, if you will. I'm going to work with the denominator fraction.
You always work from the bottom up.
It doesn't, sometimes you might have fraction plus a fraction in the numerator. It doesn't matter. but what I'm going to do here is, what's the common denominator of x plus 2 and an x? Remember, they're terms here, guys, they're terms.
Well, there's X in it, I think, because they're both
Square
square.
plus 2x.
Okay, you make it more complicated than you need to. This is a term, right? Is this a term? Can I just write it as x times x plus 2? You could say x squared plus 2x, but it's just kind of, you don't have to.
Oh, I get it.
Because I can't split apart the x plus 2 because of the addition sign. So I can't say they have a common term of x because of that plus sign. So what does the 1 miss? An x.
Multiply.
So what's 1 times x?
X.
What's the 2 missing? I didn't write the 1 times it.
Right, but why is there an
See how this already has the x plus 2? It's missing the x.
Oh, you're,
Okay.
got it.
I don't have to worry about anything with the denominator part here because it's multiplied out. Yes, sir?
If it's like a division sign, wouldn't you just like go with the order of operations, flip the thing around and multiply 1 over x plus 2 by 2 over x plus 2 and then add it to the...
We have to figure out what this is first before we can divide it out. We have to simplify that first before we can do it.
Oh yeah, 'cause yeah.
Okay. So now, this numerator is x plus 2 times the quantity x plus 2. We could simplify that out to be x plus 2x plus 4. What's x and 2x? So we have just simplified the nasty looking denominator. So now we're left with that. Again, it's the same thing as 2/3 divided by 1/2. Rewrite it. And how do you divide fractions? You multiply by the reciprocals. And the x plus 2 is dropped out. Is there anything else that simplifies? Your final answer is 2x, 3x plus 4. Again, all we had to do here, there's no addition problem that you have to worry about in this first part, but in the second part there was. The common denominator was relatively straightforward. X times x plus 2. Distribute back and forth. Combine like terms and rewrite it horizontally to look like a problem you did yesterday. And when you did that stuff yesterday, you multiplied by reciprocals. See what drops through. Again, this is more complex. You can do this one. X plus 5 plus 4 divided by 8 plus 1 over x. Try and come up with your common denominators and walk yourself through it. What's the common denominator at the top? If I put this over 1, it's going to be the common denominator. 5. Okay. This one has the 5. This one needs it. So what's 4 times 5? What's the common denominator? X. This one doesn't have it. This one does. Rewrite it. I know I have to divide by this fraction, so can I write it automatically as multiply by the reciprocal? Is that okay? If you want to rewrite it one more step, that's fine. But if you remember that you're dividing, then just multiply it by the reciprocal, you're gonna get the same result. Since it's a division problem right here, does anything drop out? No. Nothing drops out. In this case here, since nothing is gonna drop out, there really is no reason to multiply things together. And the reason that you don't need to worry about that is because now that you've gotten to this multiplication problem, like yesterday, if something would have dropped out, you would have been able to cancel things out. But here, nothing's canceling out, so there's really no reason for us to multiply it together. If you want to, it's fine. I'm not going to mark you wrong. Okay? That's kind of what we're looking at today. Okay? They give you the problems for tonight. Where did I write them at?
That bad, you didn't.
This is 9.5.